Okay guys, next we have to calculate the capacitance of capacitor which are either connected in series or in parallel combination. Now in order to analyzing an electronic circuit, it is often desirable to know the equivalence capacitance of two or more capacitors that are connected either in series or in parallel combination. First we will define the equivalent capacitance. What is mean by equivalent capacitance? Equivalent, sorry. This is capacitance. By equivalent capacitance, we means the capacitance of a single capacitor that can be substitute for the combination with no change in the operation of the rest of the circuit. Like if we have two or three capacitors which are in a circuit, such that if we replace all those 2-3 capacitor by a single capacitor such that the operation of the circuit does not change, then the capacitance of that single capacitor is called equivalent capacitance. Now normally the symbol of capacitor is this one. This is the symbol of the capacitor. So you have to differentiate this symbol from the symbol of a battery. The battery symbol is this one. One terminal is, the length of one terminal, one side is smaller and the other side is bigger. But here both these have the same length. So this you have to differentiate between the symbol of a capacitor or the symbol of a battery. Now capacitors can be connected in two ways. The first way is capacitor connected in parallel, or we can also say that parallel combination. Now here I will consider three capacitors. They are connected in parallel way. So these are three capacitors. This capacitor is a capacitance, let's suppose it's C1, this one is a C2, and this one is a capacitance C3. And these capacitors are also connected to the battery. This is the positive terminal of the battery and this is the negative terminal. So here we can see that this is the symbol of a battery because this length of this side is smaller than the length of this side. Well, these are the symbol of a capacitor because length of both sides are the same. Now these are three capacitors which are connected in series. Let's suppose this is point A and this is point B. Now, how I can identify that this combination is a parallel combination? For that, we will use the concept that if I move from point A to point B, then I have different paths to move from A to B. Like I can move from A to B through this path, I can move from A to B through this path, I can move from A to B through this path. So it means that I can write it here. The first property is, in traveling from A to B, from A to B, point A to point B, we can take any of several paths. Like in this case, we have three paths. Several paths, each of which goes through only one of the parallel element. One of the parallel element. Like if we move from A to B, we have different paths. In each path, we can goes through a single capacitor. Then such type of combination is called parallel combination. The next property of this parallel combination of capacitor is the second property. When a battery of potential difference V, when a battery of potential difference V is connected across the combination, across this combination, then what will happen? The same potential difference V appear across each capacitor. Like here we apply a potential difference V, so the same potential appear across this capacitor, appear across this capacitor, and appear across this capacitor. But the total charge that is delivered by this battery, third property is the total charge that is delivered by the battery is shared among the capacitor. What it means? Suppose this battery which deliver a charge Q, total charge, then charge Q1 is produced on this charge Q2 produced on this charge, and charge Q3 produced on this capacitor. So the total charge divided into three parts now. Q1 charge induced on this capacitor, Q2 charge induced on this capacitor, and Q3 charge induced on this capacitor. So I can say that the total charge delivered by the battery is shared among the three capacitors, Q1 plus Q2 plus Q3. This is the charge induced on capacitor C1. This is the charge induced on capacitor C2. This is the charge induced on capacitor C3. So their sum is equal to the total charge delivered by this battery. Now we know that we have a relation Q is equal to CV. So it means that potential is the same, potential difference is same across all the three capacitors. So we can say that charge induced on capacitor C1 is equal to C1 times V. Similarly, charge induced on capacitor C2 is equal to C2 times V, and charge induced on capacitor C3 is C3 into V. Now putting all these values in this equation 1, we have Q is equal to, for Q I put CV is equal to Q1, which I replace by C1V, plus Q2 which I replace by C2V, plus Q3 which I replace by this one C3V. Now potential is same, so it cancel with each other. So we have C is equal to C1 plus C2 plus C3. Or we can say that this is the equivalent capacitance, C equivalent, which is equal to C1 plus C2 plus C3. Now if there are n capacitors which are connected in parallel, then the equivalence capacitance will be C1 plus C2 plus up to Cn. I can say that C equivalent is equal to sum over I Ci, where I started from 1 up to n. This is the equivalent capacitance of n capacitors which are connected in parallel combination. Now to find the equivalent capacitance in parallel combination, from this equation we see that in order to find the equivalence capacitance of a parallel combination, we simply add the individual capacitance. Like we have to find the capacitance of C1, capacitor 1, capacitor 2, capacitor 3, then we add them and get the equivalence capacitance. Now if we see here, the equivalence capacitance is always greater than the capacitance of individual capacitor. So this equivalent capacitance is always greater than individual capacitor. So this is all about capacitor in parallel combination. So next we will calculate the capacitance of capacitor which are connected in series. I can say that yes, capacitor connected in series we can also call it series combination. So the length of this video is almost 13 minutes, so I will do it in the next video. Thank you.